Welcome back. So in last lecture we discussed about how to identify the tsunami deposits, and we discussed mostly the example from Andaman, the research which we did at IIT Kanpur. Now a few more things which are left out in this part is about the what we observed in the coral microatolls. Okay, and I have already discussed this part, this map which you see on your screen about the land level changes which took place during 2004 Sumatra Andaman earthquake. So let's see a couple of signatures which were preserved and which clearly indicated as the uplift which took place in the area along the west coast of Andaman. So the examples which I am going to talk now is from this, that is North Reef Island and Interview Island. Now these are the satellite images of the area. This is your North Reef Island and this is your Interview Island. And what we see here is the emergence of the coast, and this is emergence of the coast is well revealed by the upliftment of the coral microatolls or coral reef on this island. So this was the image taken before, and this was after, which clearly indicates the area was uplifted due to 2004 Sumatra Andaman earthquake. So what we did was we conducted field work, and as I was showing one example from Japan in one of my previous lectures, that the dead microfossils or the dead living organisms or the shells were been dated to identify the old earthquake that was that occurred during 1700 AD and 1923 or so. So this was the signature which we identified because of the uplift, the land was risen up, and the highest survival layers highest survival line for the organisms were exposed. So if you date this, then this will give the age of the uplift. Similarly, we also did some field work close to Mayabandar, where we with the help of the local people who were staying along the coast, we reconstructed that what was the higher water line, and then after the earthquake, and in 2006 and so on, and that helped us in identifying and understanding that how the land level change affected the local environment. And so this was the part which we were talking about, that the different stages of the formation of the corals, and we discussed that usually the coral will grow vertically up and try to reach the higher level of survival, that is your low tide, and then it will keep developing or will start developing on laterally, so vertically as well as laterally. So these are the signatures which we will see usually when we are having the growth of the coral with respect to the sea level. So if there is some change in the water level or sea level, or because of the area getting uplifted, then the exposed part will die, and then the coral will keep growing laterally. So you will see a sort of a shape of the coral which we can term as an hat shaped coral. That is, you will have the edge like this, and then the top will be exposed, which is dead part, and the coral extend its, because this will be the higher level of survival. So the corals will keep growing like that. Okay. Whereas this part, which was exposed because of the uplift will die. So this part is the dead coral, and this is already with respect to the SLS, here it will keep growing laterally. Whereas in the case of the land level change, where there is an subsidence, okay. So this was an uplift, and this is your subsidence. So if there is a subsidence, then the corals will keep growing further vertically as well as laterally. So this part is the older one, and this is the new one which is coming up. So this is an indicative of the uplift, okay, and gentle subsidence. This is gentle subsidence, and this is. And so now, for example, if you look at this one here, so this is an abrupt uplift here. So you have the abrupt uplift, and when island subsides, the coral continues to grow upward. Okay, so uplift will expose the coral, but the subsidence will again allow the coral to grow laterally. So this part we have already discussed, so I'll just go ahead. Now coming to this important part, which was been collected from Professor Kenji Satake from Earthquake Research Institute, University of Tokyo, about the giant tsunami in Holocene and geological and historical evidence. Now if you look at Japan, then what we see is that we have the very prominent subduction zone, which we call as the Japan Trench, and where the Pacific plate is subducting below the North American plate as well as the Philippine plate, and then we are having the Philippine plate subducting below the Eurasian plate. So it's a very complex tectonic setting, and absolutely ideal for triggering large magnitude earthquakes and tsunamis. So in 2011, this was the wave condition of the tsunami which was generated by a 500 kilometer long rupture. But as I told in one of my lectures, that the effect was much greater, as it was envisaged based on the 500 kilometer rupture because of the submarine landslide. So new inputs which came in during this survey, that is just after the 2011 Tohoku tsunami deposits, and what it was been found that usually what we do is that we to identify the paleo tsunami signatures and the inundation because of the paleo tsunami which took place during the ancient or historical and prehistorical times. Then what basically we take is the extent of the sand or the deposits which are indicative of the past tsunami. But what then usually what we used to do is that we used to say that, okay, fine, if we found sand up to this point, then this was the inundation limit of the particular tsunami. But in 2011, because it was the live case, and the scientists were able to look at the deposits and the inundation limits, what they found that even the mud dominated portion which was carried by the or the mud dominated portion also indicated that the tsunami not only just stopped here, but the tsunami waters enters further inland. So this is the distance which has been shown from the coast. You have 0 to 4.5 kilometers, but otherwise usually what we used to take is that the sand stopped here, so we will say that, okay, fine, the inundation was 3 kilometers only. And this information is important when we are talking about the modeling part. So based on this this information which we collect from the past tsunamis, then we incorporate this information in the tsunami modeling or the tsunami simulation, and that gives us the inundation heights and all that. But here this was an additional information which we got, which is again an important, and that also indicated that we need to relook at least some locations to understand that the inundation was limited to a few kilometers, or the inundation was much higher than it was envisaged. So these are the signatures, very much similar to what we were talking from Andaman. In the section, what they found was that the 869 was one of the major tsunami event in Japan, that was named as Jogan Tsunami, compared to or in comparison with what you see in 2011 Tohoku. So Tohoku was also considered as a similar comparable event to 869 Jogan Tsunami. Now Japan has a very good historical records, whereas in India we fail to have such type of records available to us. So in other sense, it becomes easier for them to reconstruct the history of past tsunamis with the help of even the historical documentation, and also they try to identify that what was the inundation and all that. And let me tell you here that they knew about this, that there is going to they are going to experience a large tsunami very much similar to 869 Jogan Tsunami, and that what they had in 2011. So this is the from Japanese chronicle records. The text, Japanese text, tells about the Jogan Tsunami, and this is the reference or the decoding what they have done. So it says that a large earthquake in Mutsu took place in AD 869. People panic striking by violent trembling. So it was a large earthquake. Houses were fallen wide open. So this is related to again the ground fissures which were developed, and about 1,000 people were killed and so on. Okay. So along with that, the teams which worked or carried out their research in that particular region also did the paleo tsunami studies and identified the limits of 869 Jogan Tsunami, and also compared their inundations which they collected based after the 2011 tsunami inundation. So modeling eventually helped them to understand that what will be the inundation pattern if a similar magnitude tsunami will be triggered. Okay. And this tells that the AD 869 coastline was located here, which was because this coastline will keep changing slightly depending on the erosional pattern as well as the sea level change, if at all it is there. So the coastline of 1869 was located almost along 1 to 1.5 meter inland from the present coast. There is the present coast here, whereas the 869 coastline was located 1 to 1.5 kilometer inland. Tsunami deposit is distributed at least 1.5 kilometer inland from the present coastline. So this they were able to compare that the locations of the Jogan Tsunami, that is your 869, the locations, and based on that they have incorporated this in their model. They also compared that with the help of different locations of the earthquakes. If suppose the earthquake occurs in the deeper part along the plate boundary at around like 330 to 45 kilometers, then what will be the scenario of land level change here? So this portion will be uplifted, this will subside, and if it is occurring at a depth of 15 to 30 kilometers, this will be the scenario, and if it is occurring in the updip portion, that is ranging from 0 to 15 kilometers, then this will be the uplift and subsidence. So during different scenarios and of earthquake occurring on the plate margin or along the plate, then different effect will be experienced on the surface. So not always the land same area will subside or same area will get uplifted. Like for example, here if we take that in the case of the earthquake which will occur at a depth of 15 to 30 kilometers, then this portion will be uplifted on surface, whereas if the earthquake occurs at 0 to 15 kilometers, then the same area will subside. So this difference needs to be understood, and this has not been done in the case of the Indian side. So we are proposing to undertake this type of studies so that at least we can come across the sequence and the cycle of the earthquake or the pattern of the earthquakes and how different it will occur in near future. So they again, as I was talking about, that they considered the past, the older coastline, and then according to that they did the modeling part. So if you carefully see this is the time which is going on and the tsunami which has been triggered. Okay. So this shows the model or the inundation of 869 tsunami. So this shows the inundation of that, and then they compared this with the deposits which they identified. So red dots are showing the location of the tsunami deposits, and based on the model also they were able to prove that this was the inundation limit. So here what they took into consideration the length of the fault and the width. The length was 200 kilometers, the width was 100 kilometers, slip was almost 7 meters, and the earthquake magnitude was 8.4, and which can produce the tsunami inundation sufficient to cover the AD 869 Jogan tsunami deposit. So if you remember, the magnitude was above 9 for 2011, and this Jogan was 8.4. So similarly, this is again a simulations for comparing both the 2011 and this one is 869 tsunami. So in 2004, if you just compare this portion here, this is the same portion. So it was, the inundation was slightly larger as compared to that. So another younger tsunamis in the sections were also identified as we had been talking. These are the younger tsunamis, some indications here, okay, where this one is your 869, whereas the younger indications of the smaller tsunamis have been reported here. Okay. Now based on this, what they were able to identify was that the comparable to the Jogan tsunami 1869 and another one was in 1454, and third one, the interval was quite significant. Okay. So almost the interval is 585 years. Now in the case which we did the similar type of studies in India, the interval which we got is much larger, that is 420 to 750 years, and that is bit comparatively large. Whatever the data we got, okay, fine, this is the best understanding we have right now up to this, but we need to narrow down this interval, what the way the Japanese people have done, like having a very precise recurrence interval. So we are proposing to do more research in that area and try to narrow down the gap which we have identified from Andaman in the record of last 8,000 years. Okay, so this is one advantage of the studies which they have done. So this was the scenario in Sendai, and these are the models which we have run for different time and how the rupture propagated. And this is the deep and shallow subsurface subfaults. If they displace along that, then what will be the scenario of with an average slip slightly larger, which has been taken as 9.5. So this suggests that the 2011 tsunami was comparatively similar, and the inundation was also quite similar. So as we were talking about that the land level change will vary, and also the tsunami waves which are generated from the different type of earthquakes will also be different. Okay, like the Jogan and 2011 were very much similar, which resulted into similar land level changes as well as the inundation. And then the 1896 Meiji Shinjuku earthquake was not along the portion which was ruptured during 2011 in Jogan, but it was up dip earthquake, and the effect which has been shown is different than what we was experienced in 2011 in Jogan earthquake of 869. So conclusions, it says that the 869 Jogan earthquake had been studied for a long time, and the recurrence interval was 500 to 1000 years, and the magnitude was greater than 8, which was estimated before this 2011 earthquake. Okay. The 2011 Tohoku was a combination of the 869 Jogan type earthquake and the tsunami earthquake near trench axis. 2011 tsunami inundated more inlandward as compared to the deposits which were been identified, that what I discussed in the beginning, that even the mud deposits were taken into consideration as an inundation limit for the 2011. Using this information, the size of 869 Jogan earthquake was re-estimated as at least 300 km long, and the magnitude was like 8.6 for the slip model which was incorporated for 2011. So possible 869 deposits are found to the north and south of Sendai plain. This will further clarify similarity or differences between the 800 that is Jogan tsunami and your 2011 Tohoku tsunami. So after that we did a short fieldwork jointly with ERI in the Sanriku area, and so this was the damage pattern during 2011, and we were looking for if we can find some more signature of similar to 2011. So this is the Sanriku area in Japan. So what we again, as I discussed in one of my lecture, that usually we try to identify the lagoonal area or the areas behind beach ridge, so that we can identify the preserved tsunami signatures. So this was the area which is enclosed because of the beach ridge here. And this was one of the ideal location for us. So when we started our field, what we identified that this portion of the mountains or the hills were completely shaved, okay, like the erosion, and this erosion of the vegetation was because of 2011 Tohoku tsunami. So you can see the level up to which the tsunami heights reached. Okay, so this whole area, the hill, is like somebody has shaved it very sharply. So these are the deposits which we were able to pick up from that area. So these are all tsunami deposits here, or sand sheets we found. And then we also did small pits to identify if the tsunami was able to climb up a small terrace and whether it deposited or not, and we found that, okay, very clearly. So this was the deposit of 2011 Tohoku, and further a deeper portion we were able to find some patches which are indicative of the past tsunami. And these are the comparisons, and based on the ages which were been done. Okay. So these are the tsunami deposits from this section. Okay. So if you see this, these are the ages here. So these are the smaller ones before the 2011 Sanriku tsunami, which has been given here, and similarly more from the same area. And we also did slight field work in the other portion of Sanriku, and as I told that this 2011 was an above the expectation of based on the previous of the Japanese people based on the previous record. So this was the level here, and this is the tsunami wall which they constructed, and just behind this, in this area, the whole settlement was allowed to occupy the area, but the tsunami was much higher than this one. So you can see the poles got bended because of the tsunami waves, and the height was much higher, which crossed this whole wall. So this was the scenario, and the energy conditions of the tsunami was much higher than expected. Now coming to the this part here, what we did was also from Gujarat area, and also we did some simulations based on our information which we gathered from the Makran subduction zone, and what was the effect here. Still we have not dated this portion or the material which we got from the Gujarat coast around Dwarka area, but yes, of course there are some indications which tells us that the 1945 earthquake along Makran was probably was much larger and was capable in generating effective tsunami which affected the coastline of Indian peninsula also. That is the west coastline of India. So we also looked at the storms or storm record from in this region they previously experienced, not only in particularly Kutch, but also the areas where the landfall was experienced, okay, in Karachi and Oman and all that. Okay. So these are the tracks which shows these storm tracks of the cyclones since 1891 to 2012. So most of the areas along this coast, that is Gujarat, southern Gujarat, and the west coast of Gujarat, got affected because of the storms. Okay. But at the same time, we also looked at that what would have been the inundation using the simulation, putting the parameters of the 1945 Makran earthquake. So what we found was the huge fragments of the rocky platform were been eroded and deposited, or you can erode it, transport it, and flipped up in the area, and that showed us very clear indication of probable tsunami deposits. Okay. So this is the tsunami generation which we did, and the height which we observed here based on the simulation was ranging around 2.5 meter. So the wave heights were 2.5 meters. So similarly, we are planning to do this work along the Andaman using different sources, not only based on the historical record, but also based on the paleoseismic studies which we have carried out from this region, and hopefully this will help us in understanding that the 2004 was not only its type of or the two powerful earthquake or the tsunami, but also other tsunamis which would have been generated from this region had a different effect along the east coast as well as along the west coast of Indian mainland, and also its effect on the other adjoining countries with the Indian Ocean. So I'll stop here and will continue if possible a few more lectures in this course. Thank you so much.